Hello, good evening. So now in this second lecture, we discuss on the fluid properties. If you remember, in the first lecture at the end, I meant all the fluid properties I set into four groups. The first group consists of mass density, specific weight, specific volume, and specific gravity. The second group is viscosity. The third group is bulk modulus, compressibility, vapor pressure. The fourth group is finally surface tension, capillarity. So this is how I summarized all the fluid properties which we generally use in our applications in the subsequent chapters in fluid mechanics. So today's discussion is only on the first group. That means we discuss on mass density, specific weight, specific volume, specific gravity, and we understand them and where we use them in our subsequent topics and some problems to understand them analytically also. That's what today's discussion is on. Straight away, let us go to the whiteboard. So now I will take the fluid properties which we are discussing today. We are discussing mass density. We are discussing the specific weight of fluid. We are discussing specific volume. Finally, specific gravity. So let me go first one, mass density. So before even discussing about this mass density, if you observe the traffic just as an observer during morning times, during evening times, in especially even in Hyderabad, we observe maximum number of vehicles on the road in a given stretch. But when it comes to around afternoon 12:30, 2 o'clock, it will not be that much traffic. But if you go to midnight, for example, still that will be very, very less. We call that morning and evening traffic as peak traffic, the afternoon thing as moderate, whereas the midnight thing we call it as very low, less traffic. What is that peak traffic? What is that moderate traffic? What is that basically very less traffic? The peak traffic in the sense that the number of vehicles that are arranged in a given stretch is very high. Whereas in the afternoon, the number of vehicles are moderate, less than peak. In the night, midnight, still less. Exactly if you, analogy, if you remember the same thing, we say in the morning, the density is so high, traffic density is so high. In the afternoon, we say traffic density is moderate. In the night, traffic density is very low. Similarly, what is mass density means it is defined as mass of a fluid to the volume of the fluid. If you take a given volume of fluid, how much mass of fluid you can accommodate in it? That mass by volume, if you put it, you get mass density. What do you mean by mass of fluid? Mass of fluid is nothing but the molecules. The number of molecules, like number of vehicles, here it is number of molecules. The number of molecules that you can accommodate to a given volume is what we call it as mass density. It is mass of a fluid by the volume of the fluid. It is represented by rho. Rho is a Greek symbol. We call it as rho. And what are its units? The units are, if you see, rho units are mass. Mass is kg, small kg, kg by volume is meter cube. So rho unit is kg per meter cube. Generally, in fluid mechanics, when we are dealing it, we deal generally with water. So what is rho water? You all should know that value, 1000 kg per meter cube. This you should never forget. Similarly, rho air is equal to 1.204 kg per meter cube. Of course, it is what I defined them is at room temperature, because rho value depends on the temperature and the pressure also. So that's why whatever I am talking here, this 1000 value and 1.204 is at room temperature, around 23-24 degrees. As the temperature decreases, temperature increases, the rho value changes. That's what precisely. So we were talking about the effect of temperature and pressure on mass density. For example, what will happen as temperature increases? Let us take it. As temperature increases, what will happen actually? Mass density decreases. Why? As temperature increases, molecular activity and molecular spacing increases. That means in a given volume, we can accommodate less number of molecules. that is mass decreases. Therefore, mass by volume, that is mass density, decreases. Right? Next, let us take it. As pressure increases, rho increases. Why? As pressure increases, we can force more molecules in a given volume, that is, mass increases. Therefore, mass density increases. Then coming to specific weight, let us take the next property. Specific weight is nothing but it is the weight of a fluid, right, per unit volume. It is represented by small w or gamma. Anything you can use it, but use one throughout. So now W or gamma is equal to weight of the fluid divided by volume of the fluid. So that is, so this is what we call it as specific weight. What are the units of specific weight? Units are, weight is nothing but force per volume. So the units are Newton per meter cube. So what is the gamma water? Gamma water is equal to 9810 Newton per meter cube, whereas gamma air is equal to 11.807 Newton per meter cube. Now, next question is, what is the relation? What is the relation between mass density, that is rho, and specific weight, gamma? So first, specific weight is equal to weight by volume. Weight is equal to mass into acceleration due to gravity. Acceleration due to gravity. So what do you mean by weight? Weight is equal to mg. Therefore, specific weight is equal to mg divided by volume. So what this corresponds to, you already know, mass by volume is nothing but rho into G. So gamma is equal to rho into G. So if you know rho, you can calculate gamma. If you know gamma, you can calculate rho. So the relation is very, very, very important. Uh, the relation between mass density and specific weight. Gamma is equal to rho g. Then next, actually, once you know this, what is the relation between this, we will go for the next topic. What do you understand, or what is specific volume? Generally, this specific volume is important, especially for gases. But however, we also study. So we study specific volumes separately for liquids and gases. So if you take liquids, specific volume is defined as the ratio of volume of fluid to the fluid weight of fluid. That means specific volume V is equal to, right, what is the volume by weight? So it is nothing but 1 by gamma. For gases, specific volume is defined as the ratio of volume to the mass of fluid. Please understand the difference. This is weight, this is mass. So if that is the case, it is equal to volume by mass. So it is 1 by rho. So this is what you should. So the units also for liquids, we can write it as basically meter cube per Newton. For gases, it will be meter cube per kg. So this is the units. The last item of this particular lesson, basically, what is specific gravity? What is specific gravity? Specific gravity of a fluid. Specific gravity of a fluid is equal to specific weight of the fluid, to the specific weight of standard fluid. It is the ratio of specific weight of the fluid to specific weight of standard fluid. What is the specific weight of the fluid, or what is the standard fluid? Generally, standard fluid means for liquids, we take water as standard fluid. Then, if that means specific gravity of any fluid, specific gravity of a fluid is equal to specific weight of fluid divided by specific weight of water. So therefore, it is equal to specific weight of fluid divided by 9810 Newton per meter cube. So this relation is very much useful for us in solving the problems. So, what is the specific weight of any fluid? Specific weight of a fluid is equal to specific gravity of the fluid into 9810 Newton per meter cube. So this relation we use it regularly in all our problems. So this is how this is being used it is being used by us in different problems actually. So what we have studied, if you see, we have discussed we have discussed about mass density, about specific weight, about specific volume, and last one is specific gravity. These are the four. Next question is what is their significance? What is the importance? Why we have studied them? Why we have studied them? What is the importance? Actually, the above four properties of fluid play a very crucial role, basically in the study of, that is what we are going to do in the study of number one, pressure measurement, number two, hydrostatic force calculations, flow through pipes, flow through open channels, flow around submerged bodies, etc., etc. So many more like that. So that is why we are studying the properties of the fluid topic. But after studying these properties, our next job is we must be familiar with how to solve a problem. Basically, let us take a problem now. Because if you understand these four, and it is very easy to solve any problem, calculate the specific weight, the specific weight, mass density, specific gravity of 1 liter of liquid which weighs 7 newtons. This is what is given. So how to solve? Given is volume. Volume is 1 liter. Because we have not studied till now liter thing. Because for us the volume means meter cube. So what it is? Conversion is 1 meter cube is equal to 1000 liters. So please note this. Therefore, given volume is how much? 1/1000 meter cube. Given weight is how much? 7 newtons. Now weight is there, volume is there. Straight away what we can calculate, specific weight is equal to weight by volume. So weight is how much? 7 Newton divided by 1 by 1000 meter cube. So it will be, if you calculate, 7000 Newton per meter cube over. Then mass density. Now you tell me what is the relation between specific weight and mass density? Gamma is equal to rho g. You just now we have studied it. Therefore, rho is equal to gamma by g. Gamma is how much? 7000. Divided by g is equal to acceleration due to gravity, how much? 9.81. So if you do it, it is 713.5 kg per meter cube. You see the units. This is mass per unit volume. This is weight per unit volume. Then what is last one? Specific gravity. Specific gravity. What is specific gravity? It is specific weight of fluid by specific weight of water. So how much specific weight of fluid, how much we got already? 7000. What is specific weight of water? 98. This is also Newton per meter cube. This is also Newton per meter cube. If you calculate 0.7135. Please note that specific gravity has no units. Has no units. It is only number. It is a number. Please remember it. So that's all. All three are over. Let me give you one more problem so that it will be very easy. From an experiment, from an experiment, it is found that weight of 6 meter cube of oil is 48 kilonewton. Determine mass density, specific weight, and specific gravity of oil. Very simple, same as previous problem. What is given actually? Volume. Volume is equal to how much has given? 6 meter cube. Straight unit also straight. What is weight? 48 kilonewtons. That means 48,000 newtons. Right? This is second. Both are clear. Now, what is specific weight? Specific weight is equal to gamma is equal to weight by volume. So weight is how much? 48,000 divided by 6. So this is Newton, this is meter cube. So 8,000 Newton per meter cube. That is over first one. Then what is mass density? So what is the relation between mass density and specific weight? Gamma is equal to rho g. Therefore, rho is equal to gamma by g. Gamma is how much? 8,000. By g is how much? 9. So if you do it, how much you are going to get? 81.49 kg per meter cube. So once these two are over, then the next one is specific gravity. So specific gravity is a number, no units. So it is specific weight of fluid divided by specific weight of water. Please always write the steps. It is the specific weight of fluid is how much? 8,000. What is specific weight of water? 9810. This is also Newton per meter cube. This is also Newton per meter cube. So finally the solution is 0.815, a number. So I have done two problems in this topic actually. So here we stop this lecture, and in the next class we will go into the most important property of the fluid properties. Very important. The whole fluid mechanics works on that principle. That we will take it in the next class. That is viscosity. So meanwhile, you study about these four properties and do 2 3 problems on these properties actually, so that in the third lecture I will take up directly the viscosity, which is very interesting and very useful, and that's actually the what you call it as more scope for us to learn. Thank you so much.
Like, share, and subscribe. Hit the bell icon for more updates.